Now for problem number 5. Calculate the total energy in kilowatt hour which can be generated from a hydropower station having the following data. Reservoir area is 2.5 km square. The capacity is 5 times 10 raised to 6 cubic meter. The net head of water at the turbine is 80 meters. Turbine efficiency is 80%. Generator efficiency equals 90%. For letter B, also find how many meter the level of reservoir will fall if a load of 20,000 kilowatt is supplied for 5 hours. Now, let's write for the given. The area is equal to 2.5 kilometer square. The capacity or the volume is equal to 5 times 10 raised to 6 cubic meter. The head is 80 meters. The turbine efficiency is equal to 80% and the generator efficiency is equal to 90%. Now the required is the energy in kilowatt hour which can be generated from a hydropower station. For letter A, the energy which will be in kilowatt hour. For letter B, the height. Now for the solution. The formula in solving for power is the formula in solving for the energy is power is equal to the specific weight times the volume flow rate times the head times the turbine efficiency times the generator efficiency given. One of the given is in the problem is in volume units, so we'll use the formula energy is equal to the specific weight times the volume times the head times the turbine efficiency times the generator efficiency given. And this is for letter A. Now let's substitute for the given. The specific weight is 9.81 kilonewton per cubic meter. The volume given is 5 times 10 raised to 6 cubic meter times the head which is 80 meters times the turbine efficiency which is 0.8 and the generator efficiency which is 90% or 0.9. Now we're going to cancel cubic meter, and what is left is kilonewton meter or kilojoule. We will convert kilonewton meter or kilojoule into kilowatt hour as what is required or as in the problem. Now we're going to multiply 1 kilowatt hour all over 3600 kilowatt hour. Now we're going to cancel kilonewton meter and kilojoule, and we're now going to solve for the energy. 9.81 times 5 times 10 raised to 6 times 80 times 0.8 times 0.9 times 1 all over 3600 equals and the energy will now be 784,800 kilowatt hour, and this will now be the answer for letter E. Now for letter B, we will find out how many meter the level of reservoir will fall for a load of 2000 kilowatt that will be supplied for 5 hours. So for letter B, the height, if the load is equal to 20,000 kilowatt, that will be supplied for 5 hours or for 5 hours. Now let's draw a reservoir. The area is 2.5 kilometers square, so this will be the level of level to be followed. So this we're going to write each here. So now let's use the formula volume is equal to area times the height to find for the height. But first, let's find for the volume because the area is already given in the problem. Using the formula, power is equal to the specific weight times the volume times the head times the turbine efficiency in the turbine efficiency in the generator efficiency given. Let's substitute for the given. The load, which is 20,000 kilowatt, times 5 hours. Now we're going to multiply 3,600 second per hour to convert hour into second and for the cancellation of the unit, equals the specific weight, which is 9.81 kilonewton per cubic meter, times the volume, which is looking for, times the head, which is 80 meters, times the turbine efficiency, which is 0.8, times the generator efficiency, which is 0.9. Now we're going to solve for the volume. 20,000 times 5 hour times 3,600 alpha equals 9.81 times alpha x times 80 times 0.8 times 0.9. Shift solve, answer equals. Now the volume will now be 637,105 cubic meters. Cubic meters because we're going to cancel kilowatt here, hour, seconds, the kilonewton here in the meter here. What is left is the cubic meter, which is the unit for volume. Let's now solve for the height. using the formula height is equal to volume all over the area. For the volume, which is 637,105 cubic meters all over the area, which is 2.5 kilometers square, but we're going to convert it into meter square, so we're going to multiply 2.5 times 1000 square equals, the area will now be 2,500,000 meters square, and the height will now be 637,105 all over 2,500,000 equals, and the height will now be 0.25 meters or meter. This will now be the answer for letter B.